Today I will explain how you could find the derivative using velocity, and this is the first example. A rock is thrown vertically from the surface of the Hope probe to Abu Dhabi will have a height s in meters. After t seconds, given by the equation s of t equals 45 minus 2.5 t squared, determine the rock's velocity 3 seconds after it was thrown. So the first thing you need to do is to rewrite the equation. So s of t equals 45 minus 2.5 t squared. And you need to know that the velocity equals to the derivative of s of t. So velocity v of t equals to the derivative of s of t. So when you find the derivative of 45, it's 0, so we don't need to write it. And then to find the derivative of negative 2.5 t squared, we will multiply negative 2.5 with 2. So it will be negative 5. And to find the power, you will just subtract 1. So 2 minus 1 equals to 1, and we don't have to write it. And then we want to find the velocity at 3 seconds. So we will change t to 3. So v to 3 equals negative 5 times 3, which will equals to negative 15 meter per second. And this is the second example that I will explain how to find the velocity using derivatives. An Etihad plane moves along a straight line with its position given by the function p equals t squared minus 6t plus 8, where p is in meters and t is in seconds. When does the velocity equal 30 meters per second? So as we did before, we will rewrite the equation. So p equals t squared minus 6t plus 8. And then to find the velocity, we need to find the derivative of p. So velocity equals derivative of p. So 2 times t is 2t. And 2 minus 1 is 1, so we don't have to write 1. And then minus 1 times 6 is 6. And the 8 equals to 0, so we don't have to write it. And then we want to know what is the velocity at 30 meters. So we will just substitute t with 30. So 2 times 30 minus 6 equals 2 times 30 is 60. 60 minus 6 equals 54 meter per second. And that's it. And this is the last example where I explain how to find velocity using derivatives. So the position of a camel moving along the x-axis of Rub' al-Khali at time t is given by x of t equals t cubed minus 11t squared plus 24t. Find the camel velocity at t equals 5. So as we did before, we will rewrite the equation. So x of t equals t cubed minus 11t squared plus 24t. And then to find the velocity, we need to find the derivative of x of t. So v of t equals the derivative of x of t, which equals 3 times t is 3t, and then 3 minus 1 is 2, minus 2 times 11, 22, and 2 minus 1 equals 1, so we will not write it, plus 24 times 1 is 24. And then we want to find the velocity at t equals 5 seconds. So we will write v of 5 equals 3 bracket 5 squared minus 22 times 5 plus 24, which will be minus 11 meter per second. And now I will explain the first example on how to use derivatives to find the acceleration. So the first example is, what is the acceleration at time t equals 4 of a skydiver whose positional equation is represented by s of t equals 5t cubed minus 24t squared plus 44. So the first thing, we will rewrite the equation s of t equals 5t cubed minus 24t squared plus 44. And we need to know that we need to find the velocity, and the velocity equals the derivative of s of t. So we will find the velocity, which is the derivative of s of t. So 5 times 3 is 15. 3 minus 1 is 2. Minus 24 times 2 is 48. T. And the 44 will be 0, so we will just ignore it. And to find the acceleration, you need to find the derivative of the velocity. So acceleration equals a derivative of velocity. Okay, so acceleration equals 30t minus 48. And we want where t equals 4, so we will substitute t with 4. So a is 4 equals 30 times 4 minus 48, which equals to 120 minus 48, which is 72 meter per second squared. And that's it. And now I will explain the last example on how to use derivative to find the acceleration. The position vector of a moving metro in Dubai is given by r of t equals 3t to the power of 4 plus 6t squared. Find its acceleration when t equals 1. So the first thing is that we will rewrite the equation. So r of t equals 3t to the power of 4 plus 6t squared. And before finding the acceleration, we need to find the velocity, and the velocity is the derivative of r of t. So velocity equals 4 times 3, which is 12, t, 4 minus 1, which is 3, plus 2 times 6 is 12, and 2 minus 1 is just 1, so we will just write t. And now we're able to find the acceleration, which is the derivative of v of t. So the acceleration equals 12 times 3, which is 36, t squared plus 12. And they want us to find when t was 1, so we will just substitute 1 and t. So 36 times 1 squared plus 12, which equals 48 meter per second square. And that's